Hello guys, welcome to another episode of Xa Talk Show. We are going to code Emacs Lisp today. Advent of Code, Day 5. Continue from yesterday. So let's show today's talk show. December 30th, the second to last, the penultimate day of the year 2022. So Advent of Code, Day 5. B, continue from yesterday, okay? Yesterday, we stuck with writing a transposition of matrix function. And I'm happy to tell you that it has been completed offline yesterday. The code is pretty short, just that, okay? And there's extra function, create matrix. Okay, so that creates a 2x2 matrix in vector, in Lisp vector data type. So it's a vector and its elements are also vectors, 2x2 matrix. You can specify 3x2, 300 by 4000, and value, initial value. Then you have the transpose function. Let's demonstrate, because this transposition function is the key to the Advent of Code problem 5. Okay, interesting problem. So let's demonstrate the transposition. Okay, so let's see. So and let me give you some news about my Emacs tutorial. You can find it. Just go to Xali Emacs tutorial. You can find Emacs tutorial initialization. Set up Emacs keys, everything you want to know about customizing keys. Emacs Lisp basics, the Lisp programming language, hello secondary account, and practical Emacs Lisp. This is all you want to know about writing Emacs Lisp to manipulate text, refactor, and supreme, okay? And then you can learn about Emacs, a bunch of tens of Emacs Lisp actual examples. Let's say you want to remove the accent characters, and each one is independent. You can copy and paste to your init file and you'll have it. So and then there's how to write a major mod. Okay, so this is my Emacs tutorial. If you like it, if you like my work, Patreon me. Okay, this is critical. This is my effort. Money is talking. So, or Amazon gift card me, or PayPal me. Okay, and I want to mention one thing, okay? Because I got the biggest Christmas gift of my life from Andrew. Okay, so thank you very much. $500. Thank you so much. And many other you guys. So let's go back to Emacs, the Emacs Lisp tutorial, and then I have a blog. So I've been writing this blog since 2006. So for 15 years, and I continuously update, enhance it, just like software, new version, So I want to say, if you like it, you can go to the page and you'll find the Buy Emacs tutorial. So what does it give you? Well, everything is free, just like free beer. But it's online. You can access it. But you like my work, pay it. Okay, pay it. You get the zip file of the entire Emacs tutorial, which is about 1,000 pages plus 2,000 pages of the Emacs manual, well formatted. That's what you get. Okay, so you can instantaneously use it as a reference or as a commitment. A lot of people wants to, they use Emacs. Using Emacs is one thing, but learning Emacs is a different thing. most Emacs users, they've been using for 10 years, for 20 years, but at least half of them, they actually never write any Emacs Lisp. So this is very powerful. You don't have to. You don't. That's the thing. You don't have to. But if you want to, it's very powerful. Emacs Lisp, I would say, is the most feature-rich and efficient programming language for text processing. Okay, that's a key. Text processing. Normally, Emacs Lisp is only useful within Emacs, as an editor. So you can create lots of features, refactor your code, key macro, or whatever. So you can write Emacs Lisp, shell, for example, shell, you don't have the shell. Eshell is written entirely in Emacs Lisp. You can go to the source code and jump to the source code. You can see here's a Eshell, and there's 400 lines here, but there's more. Okay, so anyway, that's the source code. So Eshell is a bash-like shell, but it's not exactly bash. Okay, but it's a bash-like shell with Emacs Lisp features in Emacs, and it's written entirely in Emacs Lisp. It's written by this John Wigley guy. Okay, he is currently the maintainer, the leader of Emacs, GNU Emacs, for the past 5 years or so. So he wrote this, so it's fantastic. So I've been using it for 5-7 years. Before I was using the shell, in Emacs you have multiple shells. You have, shell, let's see. So you have Eshell, you have multiple. Anyway, so yeah, I was talking about Emacs Lisp. So Emacs Lisp is a programming language embedded in Emacs, or you can think of it the other way around. Emacs is actually just an environment supporting Emacs Lisp. So Emacs Lisp is kind of like the Lisp machine of the 1980s, and mostly 1980s, the artificial intelligence Lisp machine. Very good. Okay, fantastic. So Emacs Lisp is a language in Emacs, but however, and generally it's not useful outside of Emacs. So if you wanna do web development, if you wanna do writing an extension for Linux kernel or for Microsoft whatever drivers or Mac OS, or you want to write a graphical user interface on desktop, on Linux, on Microsoft Windows, or on Mac, you cannot use Emacs Lisp. You have to use Java, JavaScript, Swift, depending on which operating system, Python, Ruby, then you need a GUI library. So in general, or if you want to write a web server or any server of any kind, a website or on a phone, you have to use other languages, because Emacs Lisp is only for Emacs, used within Emacs. You have to use Java, C, or if you want to write a game, usually it's C++, because it's a dominant language. C, C++, Java, C#, D, that's one category of languages. Then you also have, of course, Common Lisp, Scheme Lisp. All these are general purpose, or Closure Lisp, or Racket Lisp, or Ruby, Python, Perl, Bash. So not counting Bash, because Bash is just a shell. But anyway, so these are general purpose programming languages. And also Golang, I cannot forget Golang and Rust, right? So many languages. And then you have functional academic kind of languages, such as Haskell, Erlang, and Rust somewhat, and OCaml, and F# from Microsoft, OCaml, or standard ML. ML stands for meta language, standard ML. Then you have OCaml, which is derived from ML. Then you have F Sharp from Microsoft, which is derived from OCaml or ML. You know, that's one family. And this ML is kind of similar in a category like Haskell. So these are functional, very kind of pure. So lots of languages. All these are general purpose languages. Okay? And Emacs Lisp is not general purpose. You only use it, it's only basically useful in Emacs. However, if your programming task is text processing, that is, you have tons of text, you know, you want to manipulate, you want to move things around, you want to move this, you know, any occurrence of, say, a link, only if they appear within some other text before or after. I'm sorry, excuse me. Too much cigarette, the coughing. So if you want to do text processing, okay, that's a major task in one of the major tasks of programming. Reports, you know, basically you want to process text, okay, lots of text. Then, if that's the thing you need to do, then Emacs Lisp is the best language of them all, okay, text processing, including processing HTML, XML, and lots of others. You know, the Wikipedia doesn't say much, but, you know, about it. Okay, so that's the point I want to make. In summary, Emacs Lisp is basically only useful for Emacs. It's not a general purpose language. However, for the task of text processing, then Emacs Lisp beats them all. Doesn't matter, it's Perl, Python, Ruby, or JavaScript, whatever. Emacs Lisp for the task of text processing beats them all. Okay, that's the point I want to make. That is the point. Why? I mean, so why is it better than them all? Because Emacs Lisp has this special data type buffer and point and lots of things to support this text processing, where you will not find it in any other language, in Perl, in Python, in Ruby, in JavaScript. Okay, text processing. However, not at scale. I mean, if you wanna process 1 billion, you know, files where each one is 1 gigabyte, then Emacs Lisp is not good. Okay, in that case, you have to go down, you know, C++ or Golang or Camel and Haskell. But for the kind of small-scale text processing, Emacs beat them all. Okay, hello JR. Have you heard of the full hard shutdown due to Windows 11 always on state? No, I haven't heard of it. What is that? I don't know. Is there something I can search? No, I haven't heard of it. Okay, so let me demonstrate the transposition function we wrote yesterday. Okay, transposition. So let's go to a brief. So this is my my Emacs init. Okay, so search for transpose. Actually, I named it matrix. Okay, so you have two functions. This one, you know, wrote yesterday, and this one. Okay, fantastic. Evaluate them. Show the pink window. The pink window shows all my command calls. You know, as I move cursor, you can see all the command calls and the keystrokes on the left side. I'm using a Vorak layout, physical Vorak keyboard, and this keyboard is Expose. I talked about many times. If you search Xia Li keyboard blog, you'll find it. Okay, many of these I recommended. I talked about it often in my video. And good news, possibly I'll be getting the glove 80. Then I'll tell you guys how it goes. This I think it's very good. Okay, so expose. Okay, and if you like my stuff, you like my talk, my tutorials, pay me. Okay, yeah, support me, do that. And for you watch my video, those of you watching my video offline, comments, or paste a link, timestamp, tell your friends, some parts interesting, show it to your friends, spread it. Thank you. Okay, so let's demo create matrix. Okay, let's just show you new buffer. So I'm gonna do that, and let's go to XOR Emacs mod. So matrix, let's say 3x2, and with the value of let's say A. Let's say A. Okay. Run it. Okay. Now go to the messages buffer. You can see that is a result. You have a 3x2 matrix, 3 rows and 2 columns. Let's say 4x2. Okay. This time let's say B. Do it. You see, fantastic. That is. Now let's write transposition. Okay. Transpose. Okay, so we want the matrix. Let's manually put it 1 2 3. Okay, 4 5 6, a matrix. Okay, we want to transpose that. Now evaluate it. You can see the answer there. It's 1 4 2 5 3 6. The columns, you see, 1 4 2 5 3 6. Transposition, fantastic. Okay, so here is a code from yesterday. Pretty simple. Okay, you can read the code and shouldn't be understand each of the function call. Look up the documentation and you will understand it. Okay, fantastic. Now close that, don't save. Okay, okay, delete that. Okay, now go back to, yeah, so let's go back. Now what we want to continue yesterday. Okay, yesterday we got this problem. So the problem is that given a text input like that, like that, and actually this is wrong. Let me fix it. There is some reason not like that. Okay, refresh. So you got this is your input, a text input. There are 2 parts. The first part is a visualization of a bunch of boxes stacked on top of each other. Column 1, a stack, column 2, several columns of boxes. Okay. Now the second part is a instruction of procedure. So you move 1 box from column 2 to 1, then you move 3 times from column 1 to 3, then you move n times from m to nth column, and so on. So you want to follow those steps, and move the way you move the box is only one at a time. The topmost box, move one box to the other, and move another box to the other. So after you follow this procedure, what is the resulting stacks? That is the problem, day 5, advent of code. And it asks you to list the topmost box of each column. Okay, so your function will return a string of letters. Okay, that is the problem. So yesterday's code, let's copy it, and let's start to do it today. Copy. Okay, so close that. So here is today. So let's start a Emacs Lisp, paste it there, pop it out. Okay, so here is the input. Okay, so we did, I'm not going to, we did this yesterday. So okay, so split the boxes, then okay, so build Xbox matrix. So we got the matrix, then yeah, we got the matrix, then convert the matrix to a nested vector. So what we are doing is that we already parsed this, and now we got a matrix where you have each row, you have like 1, 2, 3, 4, 5, 6, 7, 8 by 9 matrix. Each row is corresponding to the row. So, but we want to represent the vertical column as a row. So we need to transpose it because we are going to, we want to operate on the moving boxes on the columns. So we want to transpose the matrix. Okay, so yesterday we got the matrix, okay, and we want to transpose, but we failed in defining this function. We spent half an hour and didn't succeed, but now we have. So we just delete that. And for example, let's evaluate this. You can see the answer at the bottom, 142536. That works. Okay, so now you just you want to transpose our matrix. Okay, our matrix currently look like that. Okay, so let's run it. Okay, you need to evaluate, okay, let's do. So that's the input. Let's just evaluate the whole buffer. Okay, do it. Okay, you can see I'm calling this command run current file. Okay, it's done. Go to the messages buffer, and you can see the result is what is the result? Let's do it again. The result is here. Okay, let's copy it. Let's make it is that, so does it represent the vertical columns? Yes. NZ, check. DCM, check. MTMTP, check. So now we got the correct answer. So this will be called stacks. Okay, so set stacks equals to that. Okay, and basically the output is like that. Okay, now we want to turn this into a, you see, each one is a vector. We want to turn them into a list. Okay, so we want to turn each stack from vector to list. Okay, so let's set qstack again. So how do you turn a vector to list? Let's check. Emacs Lisp. Okay, I have worked on a lot yesterday. If you go to my blog, yesterday I worked a lot enhancing my tutorial about the data structure, data type, vector, list, sequence, so now it's much better. I'm still working on them to improve. Okay, so stacks, you want to turn a list, you want to turn a vector into a list. Okay, so vector, let's see, join vector, convert list to vector, convert vector to list. Append is what you want to do. Okay, so append, you want to, so the sequence is gonna be vector. Okay, something like that. So the stacks is a vector of vectors. So you want to map each row to turn them into a list. So let's map. Okay, so actually you need map C. Okay, map C, actually you want to map car. Map car returns a list. Actually, we don't care about the result, so let's use map C. Map C is like JavaScript's for each. Okay, when you don't care about result. Okay, so the sequence is gonna be stacks, and the body, this is what we want to do, body, which is this append x. Okay, append takes a bunch of sequence. Sequence means either list or vector or string in Emacs Lisp. Okay, so append, basically they return a list. Okay, warning, if you wanted to return a proper list, the last item must be a list or nil. Okay, that's a quirk in Emacs Lisp and in Common Lisp too. You have to put a nil. I'm not going into the detail, but basically you can, if you want to know the detail, read about const pair. Okay, that's why you need to understand the nil. Okay, so anyway, we are turning a vector into a list. Okay, so that. Okay, so map C. Okay, well, map C doesn't return anything. Let's say car. It will just change the whole thing into a list. I don't want to change the whole thing into a list. So yeah, append returns a list. List is very annoying. Yeah, it returns a list. Okay, result a list. Yeah. Okay, let's do this then. So map car that into the stacks. So we got this will turn the whole nested vector into a nested list. Okay, let's do it. Oh wait, wait a minute. Let's see. So we are mapping this function to the stack. So we turn them, each one of them, into a list. So that means each row is now a list. Okay. And then we set the result back to stack. So now stack is gonna be a list. Okay, let's run it. Run it. Oh, void variable stacks. What? Wait. What's going on? Didn't we? Oh, okay, let's run this. Run it. Okay. Now, run it. Okay, now it works. Let's see. Yeah, you see? That's the result. You see, they become parentheses, which means a list. But now you want to remove the empty, the empty list. So you want to map again. Okay, so let's seq x stack. Okay, then you map car. Okay, map car on sequence. Okay, and the sequence is gonna be stacks. Okay, and this time what you're gonna do, you want to kind of filter. So if the list start with a empty string, remove it, okay? Because empty string is like, okay. So, okay, so now Emacs Lisp again. So we are working on list. So what to do? Okay, I know what to do. We can use a filter function, but we don't want to do that because the filter function will go all the way. You see, in our case, we drop the first item if it's empty string. But however, the empty string, as long as, when there's item that's not empty string, the rest will not be empty string. So the empty string only happens in front. Okay, so if you use a generic filter function, test if element is an empty string, that will go through the whole. We don't want to go through the whole, because once we found an empty string, we'll stop. Okay, so that's more efficient. But however, if you use a generic filter function, there's one here, sequence filter, that will just, blindly, if you have a million items, you just keep checking. We don't want that. So anyway, so our function will do if car x is a list. Okay, if car is a string equal, if the first item is empty, actually let's use a length. Okay, if length car x is equals to 0, okay, equal, let's say 0. Let's use the string equal because it's more clarity, because it tells you it's a string and it's empty string. This will work too, but it's, what if you have an empty list or something? That won't happen, but anyway, this is more clear using, okay, so string equal, if it's empty, then you want to set x equals to cadre of x. That means drop the first one. You can just do pop, okay? Drop the first element. Otherwise, do nothing. So you need to put this into a while loop. So while that is true, then pop. Okay. Okay, so let's put this into, so we don't need that. So the function will take on x, which is one of the row. So while string equals to pop x. Yeah, I think that's it. Okay. Okay, let's see. Let's hope it's not infinite loop. Okay, make sure we back up and all. Run it. Neo. That's incorrect. Let's see what is stack. Okay, that's incorrect. Okay, so we need to get our stack back. Run this. Okay. So that's our stacks. Yeah, that's like that. Yeah. And now go through stacks, map it, append, which turns it, turn it. Okay, convert from vector to list. Hello, condemned. Condemned, did you send me an email about your Emacs tutorial? I don't think I see any email. Check your spam folder. Maybe it's in your spam folder of Emacs tutorial. Okay, am I still going good? Am I doing good, guys? Okay, convert it from vector to list. Okay, let's run this. Run it. Correct. At the bottom now. So now you have a list of list. And now you want to, oh, you don't want to map car. Wait, God, this, this, so while you pop, that's right, but you want to return the X, that's why. Okay, you pop, you drop the first item, then when it's no longer true, you want to return the rest of it. Okay, so that, run it. Fantastic. Go to the message buffer, copy it, paste it here. So that is our stack. Okay, the state. So we got the stack. Okay, now let's move on to the next part of the problem, which is to turn this procedure in English into code. In other words, we are writing a transpiler. We are compiling English source code into Emacs Lisp source code. Okay, so let's read the comments. Pinoy boy, I bought the Xbox keyboard. Okay, thanks. I just discovered your site, and for sure I'll support. Thank you very much. Thank you. You inspire me to buy the Xbox. Yeah, very good. Deep dive in learning programming. Thank you. What do you think about Spring Boot framework? I don't know. What is that? Spring Boot. Is that Java thing? I don't work with Java. Okay. Spring Boot introduction. Spring Boot is an open source Java based. Yeah, I don't code Java. Okay. Yeah, I don't know anything about it. Okay, so now we want to turn this into a, English into code. So first of all, so we actually this part is already here. So actually, let's copy it. This procedure. Let's see. Describe variable. What? Procedure, you see, it's already a list. Okay, so the value of that is that. Okay, let's see, procedure text. Okay, let's change the name. Okay, so that is the procedure text. Now let's go to the bottom. Now we want to do something with that. Okay, let's create a variable. Let's say input numbers. Let's say procedure args. Okay, that is, this English, we want to extract just the numbers. Okay, because the move from to, it's not important. We just want to get the numbers. Then we write a function that deal with these numbers. A function that takes these arguments. So procedure args. Okay, now let me show you guys something interesting. Okay, because typically, in other programming languages, you manipulate strings. Any text is a string, so you call string functions like, string trim or string, get index from n to m. But in Emacs, let me show you the text processing. Okay, so let's do that. Very different from any language, because only Emacs Lisp has that uniquely, like we talked about before, text processing. So this procedure text, you can, let me show you, okay? With tempbuffer, okay, we create a temporary buffer, then insert this procedure text, this thing, okay? Then we insert it into the buffer, then delete. We want to delete all the words move from, okay, and to, okay? So we can do while, okay, first of all, go to char, go to point mean, which is the beginning of the buffer, 1 position, okay? Move the buffer to the beginning of the buffer. With tempbuffer, create an empty buffer like that, okay? Then you insert, it just insert, it just insert whatever, that string procedure text. Then you go to the beginning of the buffer, then you do a while loop. So while search for word, let me show you, okay? So while search for word, move, okay? And bound, we don't care, neo, no error, true, okay? Count, we don't care. So you search forward for the move character. If it exists, delete it. I mean, if this function found it, then it will return true, okay? So this while loop works. So if it's found, then you want to say replace match, okay? Replace match by empty string, so fixed case and all that, we don't care, okay? So yeah, delete that, okay? So this part, let me show you, okay? Let's do it this way, okay? So these 2 lines will delete all the word move, okay? Now we need to repeat this, okay? Now change the word to from and change it to 2, okay? Or we can combine these 3 lines using a regular expression, okay? But let's just stick with this, simpler, okay? So remove the move from 2 words, then, okay, then return the string, okay? So we want to, so let me show you how this is done, okay? We want to set this yeah, let's do it. Okay, so let me show you some, okay, let's do it here. Okay, let's say set x1. Okay, copy that. Okay, so that we can see what it actually returns. Okay, so let's do it. Oh yeah, so at the end we want to this with temp buffer, it will return whatever the last expression returns. So we need to put the text here, so it will return the string, then set it to x1. Okay, so with temp buffer, the last expression will be buffer substring no properties. Okay, position point min to point max. Okay, that will return it. Now let's do something else. I mean, once you get that, so you remove all the words, then you also, let's just do that. Okay, so let's evaluate this part. Evaluate it. Can you see? Beautiful. That's the result. So you could, then all you have to do is split string by empty by a new line. Okay, wait, split string x1 by empty by a new line character. Okay, and omit nulls. That's true, we don't want anything. Okay, so yeah. Okay, so let's do it. You see, it becomes a split string x1. Oh my god, coding takes a lot of time, and now I feel like I need to get up and walk. Okay, and we also need to trim string. Okay, so god, let's combine this. Okay, let's try to combine this into one expression. Okay, so research forward. Okay, so the rejects is going to be several. In Emacs Lisp, you need a lot of that. Yeah, very annoying. Move. Okay, so move from to. Okay, that's how you do them in one shot. Okay, so optional bound nil, no error, true, count, we don't care. Okay, yeah, so these 3 lines is now just this one single line. Okay, regular expression, the power of regular expression. And we can run it, and so you can see, you see, and then two, so we want extra space there, so let's run it again. Run it. Fantastic. Okay, so now let's remove this redundant one. Okay, and now let's shorten. Okay, and now we split the string. Let's run it again. Okay, now run it. I got the slash wrong. It should be backslash, not slash. Okay, yeah, that's right. Okay, so you can see, fantastic. Okay, now so we can put the split string, combine these two. Yeah, let's do that. So this whole x1 let's just put it here, okay? And okay, let's put x1 here, okay? Okay, so if you run that, you get that, okay? That's x1. Okay, a list of strings. Okay. Okay, string args. Okay, let's rename them. Okay, args string. Okay, let's just rename them so it's easier to understand. Okay, now we don't want that. Okay, now we want to write a function such that when the function takes a string of numbers, then it will manipulate our stacks by following this procedure. Move it, Okay, let's write move. Let's define that function. Define. Let's say move stacks. Okay. Okay. String. Okay, so actually it should be xyz, 3 arguments. Okay, xyz. Okay, so it's gonna be xyz, 3 arguments. Okay, move y, move 1 box from y to z x times. That's what it means. Documentation. Okay, we don't need interactive. Okay, then that's the body. So what we're gonna do, so xyz, so from stack y to stack z, okay, and do it x times. Okay, so oh god, back. How are you guys? 6 people watching. Say something. So we already coded almost 1 hour. Coding takes a lot of time. This advent of code, fuck. Okay, so move stacks. Okay, yeah, that's kind of boring. Okay, so here is our stacks, and our stacks is a list of list. So stack number 1 would correspond to, stack column 1 would correspond to our stack index 0, nz, like over here, so that's our stacks. So okay, so the data structure we want to manipulate is this. Okay, so let's see, move y to z. So that means, God, move stack y to z 1 time. Okay, so stacks, so it's a list, right? So what you can do is, you first of all, what column? Yeah, well, column y to column z. So you want pop, so you want to do, so pop God, this fucking, so pop and read We don't want a list of list. We want a vector of list. Fucking stupid Emacs Lisp. Let's fix this. So here our stacks is a list of lists, right? A list in Lisp, list is efficient representation of stack, okay? But however, efficient representation of stack, which means you can push or pop the first item. But however, when you access nth item, it's slow. So the whole thing should be a vector, or in other words, array. So you can access any column very fast. But for each of the column is a list you can push and pop very fast. But the whole thing should be a vector. Okay. Why am I concerned about this? Because if it's not a vector, then our problem right now is we want to pop the wide stack. So how do you do that? The wide stack would be something like something like that. It's a bit fishy because when you have a list, it takes nth time to get to that column, and also you have to worry about, do they update the variable or not, or do they just return? If they just return, you need to set it back to the variable. And also because each column, our stack is there's only one variable represent all the stacks. So when you change any one of the stack, you have to reset the whole thing back to stacks. You see, meaning that you have to do something like this. Okay, set q stack by. You cannot just do this because this will just return the topmost item of the column Y. So you need to get the whole stack, that's why it's cumbersome with the list. Because when you have the whole thing, if it's a vector of lists, then you can just say then you can say a ref. Okay, let me show you how it's done. Okay, so you can just say yth stack to zth stack, and here array is your matrix. Okay, then you can update by something like this. Okay, set a ref. Okay, what's a vector form? So vector, you want to change one element of a vector, a set. Okay, yeah. So what you do is a set. Okay, your array is your matrix. A set push and pop. So you want to pop Y, push Z. Okay, so there are two change, pop Y, push Z. Okay, so let me comments, questions. Okay, very annoying. Okay, so you want to, so first of all, push, let's do push pop, okay? Pop, push, okay? Now, pop, set box equals to pop y stack. So if it's a vector, then would be a ref, okay, and array y, okay. So that is the one box. You pop it out. And then you want to then you want to push Xbox into array ref z. Okay, that's how you push and pop. You take one item from stack y, then you say X stack. Okay, then you put that item to the zth column. Okay, after you do that, you need to reset your whole stack to the new thing. So pop and push, pop and push, you pop and you push. Yeah, you pop and you push, then it changed your stacks variable, the value. No, it doesn't change, actually. It doesn't change. So therefore, you need to set them. Yeah, so okay, I don't like using this. Actually, it changes the vector. Lisp bar. Oh, are you a Lisp? It does. I mean, but you see, we have a vector of list. Assuming we have a vector of list. So we are doing push and pop of the list inside the vector. Oh, it does. So you are saying it does change the okay. I think you are right. I think okay. Maybe you are right. Let's try it. But first of all, do we want to turn this into a vector of list? I mean, turn this into a vector of list or not? Maybe not. Okay, let's get it to work first. Let's worry about whatever later. Okay, let's assume it's just a list of list. Okay, so stack is a list of list. So now we need to write this in terms of list. So nth, let's see, nth, okay, nth, return the nth element, okay, yeah, oh, and 0 indexed, but the number here is 1 indexed, so you need to minus 1. Fucking idiotic fuck. Yeah, you have to minus 1. So okay, let's do it. Decrement, okay. So nth, the nth, you pop it. Yeah, but you cannot set. Okay, so you don't need to set. Let's assume that. Yeah. So you pop the nth, and then you push. Yeah, then you push. Okay, so this, you just push this thing. That's a new item here. You push it to the Z list, right? And assuming it does the setting of the variable. Okay, so let's remove this. Let's hope maybe that's it. Then you have to do this y times. Let's ignore it for now, okay? Let's ignore it. So now we just evaluate this function, and let's test on this function. Okay. You know, last time I did Wolfram language, I realized this, when you modify things, it's not good for functional programming. Let me explain quickly. I want to move on, but this is important. Because now we want to test if this function works. However, if we run it, then call it, you know, no expansion stack, okay, move stacks. Okay, if we call it with some number, then it's actually gonna modify this. So when we want to test again, we have to freshly set our stack. Can we do that? Yeah. So after each test, we have to reset the stack. So where does it take value from? Stacks. Okay, so these two needs to be combined into one. You know, we are writing a lot inefficient code. These two needs to be combined into one. But anyway, so where does the stack? Okay, starting from here. Yeah. So yeah. Okay. So we will. So okay, let's push on. So let's move stack. Or alternatively, you know, what I'm thinking is that you put these stacks as an argument there. That way, you know, then you stop using the pop, you know, and stop using push, you know, functional programming. The whole thing just return a whole new nested list of stacks. Then when you want to repeat, you know, the move 3, you know, then you just reset, you know, then you can do while or do times. That way, you know, that way is functional programming. Okay, but anyway, let's push on with this. Okay, let's evaluate this. Okay, move stacks is there. Then let's say 1 to 1, the input 1 to 1, which moves D to the first column. So the first column will be D and Z. So run it. Wrong number of arguments. Yeah, okay. So so that's why. So we just remove that, okay? Copy. Evaluate, run it. D and Z. Fantastic. But that's only column 1. Why does it just return column 1? oh yeah, when you do push. So you see this function, we don't care about the return value. It just state manipulation, procedural programming. Okay, but it works. Okay. So does that mean we kind of already solved the problem? Yeah. Then we just need to map. Yeah, okay, let's get map C. We don't care about the, you see, we want to map to the arg string. For each arg string, we want to split by white space. Okay, emit nuance, no. Okay, so this will be the argument. Then we just call move stack. Then we gotta splice it. Fucking idiotic fuck. Let's turn this into a list then. Emacs Lisp. So the problem here, the function takes 3 arguments. Well, you can, but now we have a list instead. So you want to turn a list into 3 arguments into here. Yeah, you can do that, but it's not. You have to use the reader macros. Fuck. Like this, okay? Tick. Something like that, okay? Splice, very annoying. Use apply. Oh, thank you. Lisp is a Lisp expert, I can tell. That's right, use apply. Apply function, rest arguments. Fantastic. So, yeah, okay, so let's use apply. Okay, let's remove that. Apply. Now apply a function. Yeah, the function is move stacks. Okay, and rest arguments. Call function with our remaining argument with our last arguments. Using our last arg as list of args. Okay. Yeah, that's right. That will work. Okay, so put that here. Now that should work. Now, does this needs to be a symbol or whatnot? I think so. And in Emacs Lisp, you have that # idiocy. I don't like that. Usually I don't want to add that. Anyway. So yeah, so apply. So we don't need that. So we apply. Oh, and we are still not doing the do it n times. It should be here. Okay, so let's add it here. Do it n times. Okay, let's clean this up. So yeah, so do times should work. Do times count y result, we don't care, and what we're gonna do is this. Okay, and since we are not using let, we don't need the whole let thing. Just now simple. Move one box from stack y to stack z. Do it x times. Okay, so yeah, do it x times. So yeah, so we don't even care about I. Yeah, just do this. Yeah, x times. Okay, so now we don't care about that. That's our function. Evaluate it. Good. Now let's see if this works. Lambda, it should work. Okay, but first of all, let's see what is when we run this, if it's correct, then it would be the answer for the question. So the answer should be CMY for the sample input, like that, CMZ. Okay, so if we do that, let's see, let's double check one more time. Xarg string is that, yeah. Okay, run it. Run type argument number marker P. Oh fuck. So is 2 times incorrect. What? Wrong type of arguments. Okay, wrong type of arguments. Oh, we got a string. Oh yeah. So we need to turn string into numbers. Yeah, we didn't do that. Yep. So okay. Okay, map car y sequence what? Wait. Split string. Yeah, so map car, that's a sequence, and let's say y we want to string to number. String to number y. Okay, that kind of works. Okay, something like that. Okay, so let's try again. Evaluate. Okay, then we need to look at our stacks. Looks like it's incorrect. Well, okay, it's incorrect. CMZ, the result should be CMZ. Okay, so but basically it should work. So let's evaluate the whole thing. Let's see what happens. Okay, and we need a lot clean up. This can be combined into one, and okay. So if we evaluate the whole thing, string to number, okay, then call move stack. Okay, yeah, let's evaluate the whole thing. Okay, and now let's see what is stacks. CMZ. Now let's write another function. Let's just to get the top boxes. Okay, so x get top box. Okay, so yeah, okay, so that okay, given the stack, yeah, this time yeah, so for each what is the structure? A list of list. Okay, car. So you want to map, yeah, so you just map car, and the sequence is stacks. And what you're gonna do, well, we're just gonna car the thing, cutter. this coding car and cutter, there it is. I don't want interactive. Okay, that's it. Evaluate it, then call it. Okay, then do that. There it is. But then you need to join string. Okay, join. So list to string. I believe the function is just join list to string. List empty list. Length get element, add to list, modify list to string, map concact. What the fuck? There it is. Map concact. What? Number to string. Yeah, nothing. We don't need any function. Identity. Now, the identity function is very interesting. It exists in functional programming languages, but not in C, C++, Java. Fuck. The identity function is a function that does nothing. Given arguments, it just returns arguments unchanged. So why is it useful? It's useful because when you do functional programming, you need this kind of thing. Like right now we are doing, we want to map concact. It takes a function name, basically, apply that function to each element of the list so that, maybe you want to turn into a string or you want to do some transformation. But in our case, our elements are already a string, so we don't want to do anything. Well, so that's why you say identity, okay? Then separator, empty string, okay? So let's run that. Oh god, then we have that. Oh shit. Those things we could, those square brackets, we could have removed it earlier, when we yeah, but now let's just write another function to remove it. Yeah, fuck. Okay, so this actually, let's put it here. So let me show you, okay? So let something that here map car, okay, wait, so you get that. So what do we have here? So map car, get the top elements, then you can join as a string, okay. Then you join as a string, then you can do string replace in rejects. I don't know what is the name. String rejects replace. Use it instead of map car. What do you mean it? Oh, you mean apply. What? Yeah, so now we need to, I think you could just replace map car with map Oh, I see. That's right. You are right. So let's see. That's right. Fantastic. Thank you. So map concact. That's right. Then we get the first element. Then we can also, meanwhile, yeah, let's just remove the bracket here. So car, okay, then you do a substring I think I'm doing what you are saying, right? I think so. So the string is that. So the string is, for example, something like that. So 0, 1, 2. So from, for example, let's try it, okay? From 1 to 2, run it, M, that's correct, okay? So that's what we want. Okay, so yeah, that's what we want. So just that, return a string, okay? Okay, evaluate it. Now let's call it. It's wrong number of arguments. Oh shit, something we forgot. What is map concact? Okay, separator, function sequence separator, function sequence separator. Okay, that, run it. Fantastic. Okay, that solved the problem. Number advent of code day 5, number 1. The sample problem. Now let's try the real input. Okay, so so pop this back, clean it, show in browser. So here is our code, advent of day 5, advent of code day 5, number 1. And now we need to check the real input. Okay, so the real input, where is it? Day 5, there it is. Okay, so let's open a new one. Can't open that. So here is the real input, 500 lines. Okay, copy it, and we can pop this out again. Let's run the whole thing just to double check. Go to the bottom, let's run this. Yeah, CMZ, correct. So now we just replace the whole input by the giant thing. Or we can do, no, let's not. Let's copy the file path. Let's do something. So let's read this file, okay? Then set it to our input, okay? Set x input by reading a file of this path, okay? And let's shorten it like that. So read a file. So so how do you do? You can use a tempbuffer and insert from file. There's a function, okay, insert from file. So let's go back to Emacs Lisp reference. So you want to read a file. So there is a you go to practical Emacs Lisp, because reading a file is not core of a functionality of Lisp. So there it is. Oh, that's right file. So you read the file. Okay, insert file contents, that's what we want. Insert file contents. Okay, yeah, so set input with temp buffer, create a temporary buffer, then insert file contents. Okay, then the file path will be that. Okay, optional visit, no. Okay, then after we insert the file content, we grab the whole text because it needs to return. Okay, so buffer string, buffer substring, that will work. Actually there is a this will do. Okay, this function buffer string will return the whole thing, return the contents of current buffer string. Okay, so that. Okay, so that will set the input. Let's try it. Run it. Fantastic. Now we can, describe variable. You can see that variable. We got it. So close this. Now just run the whole file. That should do. Okay, run the whole file. Problem. Args out of range. Fuck it. String trim. Where does it come from? String trim. Okay. String trim. Right. Copy. I wanna see string trim. These matching lines. Okay. String trim only happen one time. So what the fuck is this? Build the matrix. Okay, stop saying boxes, just say matrix. Okay, whatever. Okay, a list of lists. Okay, so what is the error message? String trim arg out of range. String trim. So it's trying to trim substring. What is a fuck string pad? Substring. We take wait, what is arg? String trim arg out of range. So string trim, so this substring is giving us errors, I think. Very annoying. You got this problem. This substring is arg out of range. And so we printed something there. What happens? Yeah. So what is this doing? So build the Xbox matrix. So build the Xbox matrix. It's building this matrix. So do you oh god, this is gonna be boring part. So debug. What we should do is actually clean up the code right now. That's a good step to do. Clean up the code, make things proper, rename variables so we don't have these, so this is build a matrix. So we are trying to build this thing. And first of all, string pad 32 is a space here. That's idiotic. String pad. we want to pad it just in case, because we are splitting them by every 4 characters. We don't want to run out of characters. Then X list is nil, and do we have like leaked variables or something? What is this X? Okay, so let's change that to Y. That should be the only occurrence there. Yeah. So lambda YY. So string pad, number of columns. Let's see what is the value of number of columns. 0. What? Wait. Number of columns. That's a problem. Our number of columns is wrong. Now what is the, okay, let's run them one by one then. Okay. First of all, input is correct. Now the input parts, what is this? This is this input. Wait, hold on a second. Copy that. Yeah, this is today. Let's put the input here. Okay. Now input parts. Okay, let's go to messages buffer. What? Close that. So that's a list of 2 things. Okay. Now box text, that's right. That's that. Procedural text, okay, that's got procedural text, that's right. Yeah. Close. Now box is line list. Let's see what that is. Okay. A list of the boxes, that's correct. Okay, and number of columns 0. This is incorrect. Number of columns. Okay, so number of columns, the way we do it is we take the last item, let's see, run it. Yeah, so that's the last line. Wait. Okay, we got a problem here. That's the last line is dropped. We should get this 1, 2, 3, 4, 5, 2, 9. So let's try again. Instead, we have this ng thing. It should be that. So here is the problem. Why is that? Now let's look up the input. The input should contain it, right? Yeah, it's there. So let's see. Input parts. Text, yeah, it's there. Box text. Box line. Okay, it's missing here. So that's a problem. So box text, we have the last line. But box lines list, it's gone. Okay, that's not. Oh, it's gone because it's dropped here. So again, this is a problem, a procedural programming fuck. Things happen, they change state. Because here, because you drop the line here. But before you drop, you need it to get the columns. So maybe we So let's rerun everything again in order. So run that, run that, run that. Then what? Run that. Procedural text. What? Then box lines list. Okay. So you see, you do have that. Then run that. The column is still wrong. What? So you do have the number, but the column is still wrong. Okay, so our code is wrong. Box lines list. How? So let's see, what are we doing? Car, last, then split string, then last and car, then string to number. Okay, let's evaluate this part. Empty string. Okay, let's evaluate that part. Empty string. Let's evaluate that part. Oh, empty string. Oh yeah, fucking idiotic. You need to drop, when you split, you need to drop null. Okay. Okay, so you need to omit null true. Yeah. Yeah. Okay. There are better ways to do this, but you know, we should actually just use a regular expression. Actually, is it faster? No, not necessarily. Anyway, so if we evaluate this wrong type of argument, what the fuck? What? Oh, we got T in the wrong place. Should be here. There. Okay. There. 9. Now it's good. Now this part we don't want, and this is super inefficient, and we don't want it here. So this should be drop the last item. Let's forget about efficiency, but this line, let's move it here. So let's do a trick so that Emacs highlight all that. The command is, you can see highlight symbol at point. Okay. Okay, but we don't want to drop where. Okay, so here we don't want to modify it. Okay. Yeah, so we yeah, okay, leave it. So we got the columns. Okay, now let's just run the whole thing. Okay, run the whole thing, and please, it works. Let's run that. Oh, there is the answer. Let's check. I think it's correct. DHBJQ JCCW. DHBJQ JCCW. We are good to go. We finished. God, finally finished. Close to 2 hours. Okay. Yee hee. Happy New Year. Okay. Now we want to exercise our Emacs Lisp muscle. We want to make this short, concise, elegant, and the fastest of all possible. It's possible to do that. It doesn't matter if it's a million, this input, a million stacks, a billion lines. We want to make sure. In fact, possibly Emacs, actually, it's possible that Emacs can do this problem faster than any language is it possible? I'm actually I don't think so. Not because in some problems it will be possible because we exploit the Emacs ability to manipulate text in a buffer. So when you have, yeah, but I'm not sure in this case. Congratulations. Hey, thank you for your help. So what we do now, I think that's it. So we can, yeah, that's it. We can clean up and explain things, but perhaps that time would be better spent, doing a new advent of code. It would be wider audience, easier problems. So right now we have done advent of code in Wolfram language up to day 7. We didn't finish day 7. We stuck. I know how to solve it, but we didn't finish in a video. So, and there are quite a lot more calendar. So there are 25 problems. We have like more than 10 to go. So we can do Wolfram language, and then we should, it would be good to do Emacs Lisp. So I'm going to do it every day. Yeah. So maybe advent of code, maybe some other problem. No, there's no hurry. No hurry. Yeah. So thank you guys for watching. Bye guys. If you like my stuff, buy my stuff. Okay. Go to xali.com, xali.info, or xali.org. There's no com. xali.info or xali.org, and pay me and donate me. Okay. And Condemned 77. If you haven't sent me email, if you haven't got your Emacs tutorial, do it. Okay. Send me an email so I know your email so I can send it to you. Okay. Thank you guys. Bye.